Hello everyone. Today we will discuss about graph theory. Graph data structure. A graph is a data structure for storing connected data like a network of people on a social media platform. A graph consists of vertices and edges. The vertex represents the entity, for example, people, and an edge represents the relationship between entities, for example, persons in friendship. Adjacency matrix. An adjacency matrix is a square matrix with dimension equivalent to the number of vertices in the graph. The elements of the matrix typically have values 0 or 1. A value of 1 indicates adjacency between the vertices in the row and the column, and a value of 0 otherwise. This representation is fairly easy to implement and efficient to query as well. However, it's less efficient with respect to space occupied. Adjacency list. An adjacency list is nothing but arrays of lists. The size of the array is equivalent to the number of vertices in the graph. The lists are at a specific index of the array represents the adjacent vertices of the vertex represented by that array index. Here we can see example. As we can see here, the class graph is using map from data from Java collections to define the adjacency list. There are several operations possible on the graph data structure, such as the creating, updating, or searching through the graph. We will go through some of the more common operations and see how we can implement them in Java. Let's see how we can create the simple graph we have drawn earlier using the methods we've defined so far. Here we can see code. In this tutorial, we will find working examples of adjacency matrix in Java. An adjacency matrix is a way of representing a graph as a matrix of booleans. Adjacency matrix representation. The size of the matrix is where V is the number of vertices in the graph and the value of an entry. A is either 1 or 0 depending on whether there is an edge from vertex I to vertex G. Adjacency matrix example. The image below shows a graph and its equivalent adjacency matrix. Java examples. We create two-dimensional arrays. We also know how to create an adjacency matrix. Here, adjacency matrix representation in Java. After that we initialize the matrix. Then we add age. Then we remove age. At the end, we print the matrix. That's it. Thank you. Goodbye.